Azure Service Fabric comes with an SDK and development tool support. Development for Windows clusters can be done in C# using Visual Studio 2015 and 17. Developing Java-based services for Linux is probably the easiest using Eclipse Neon. It's also possible to program in C# using .NET Core and Visual Studio Code. There are 4 different programming models you can choose from if you want to create a Service Fabric application: reliable services, reliable actors, guest executables, and containers. Reliable services is a framework to create services that use specific features that Service Fabric provides. One important feature is the distributed storage mechanism. Others are custom load and health reporting, automated endpoint registration, which enables discoverability and interaction between services. There are 2 distinct types of reliable services you can create: stateless services and stateful services. Stateless services are intended to perform operations that do not require internal state to be kept. Examples of this are services that host ASP.NET Web APIs or services that autonomously process items they read from a queue. Stateful services keep internal state. This state is automatically stored redundantly across multiple nodes for availability and error recovery. The data stores are called reliable collections. Note that reliable collections aren't supported on Linux at this time, so stateful services aren't available either. Reliable Actors is a framework built on top of reliable services that implements the virtual actor design pattern. An actor encapsulates a small piece of state and behavior. Examples are so-called digital twins, where actors represent the state and abilities of a device in the real world. Many Internet of Things or IoT applications use the actor model to present the things. The state of an actor can be volatile or kept in a distributed store. This can be either in memory or on disk. You can also package and run existing applications as Service Fabric stateless services. This way, applications are made highly available. The platform ensures that instances of an application are running. Applications can also be upgraded with no downtime. Service Fabric can automatically roll back the deployment if problems are reported during an upgrade. Finally, Service Fabric enables you to run multiple applications together in a cluster, which reduces the need for hardware resources. It is important to note that you cannot use some of the platform capabilities, like reliable collections, when using guest executables. Containers can be run in a way that is similar to running guest executables. Running containers is very similar. What's different is that Service Fabric can restrict resource consumption, like CPU and memory, per container. Limiting resource consumption per service enables you to achieve an even higher density on your cluster. This feature is in preview at this time. It allows you to specify an image, which Service Fabric will then run on the cluster. This is a great way to run legacy software on a cluster combined with newly created Service Fabric applications. From container to host and endpoint registration enable you to deploy multiple containers and have them communicate. To run a container in Service Fabric, you need to create a service type that is configured with at least the image name. Service Fabric will automatically pull the image to the cluster node and start the container. If the container crashes, it will be restarted automatically. You can combine running containers with guest executables and reliable services and actors together on one cluster to make optimal use of its server resources.